All right, ladies and gentlemen, welcome back. We're talking about solving equations this time with multiplication and division. So this is going to be still one-step solving. There actually might be a couple that have two steps, and we'll talk about those if they have a fraction. So we're talking about the multiplication property of equality and the division property of equality. And similar to the movie you watched on addition and subtraction, we see that for any numbers A, B, and C, if A equals B, then I can multiply the same number to both sides of my equation, and I'm not going to change it. And similarly with the division property, for any numbers A, B, and C, with C not equal to 0, okay, because I can't divide by 0, that's not possible, that if A equals B, then I am able to divide. Again, C can't be 0, but any other number I can divide on both sides of my equation, and I keep everything in balance. So when I see an equal sign, I always think of kind of a scale and what each side of that scale is equaling, and making sure that I always try to keep it in balance. So we're just going to practice here solving some equations. Remember again that our goal still is to isolate our variable. We want to get our variable all by itself, and so I need to do the opposite operation in order to make that happen. So this right here, if I think about this in words, it's saying -4 times what number is going to give me -28. And I know some of us can think about that in our heads and know it, and here's how the math around it kind of works. So if this is being multiplied, then I want the number, if I want to isolate this R, I need the number in front of it to be a 1. So I'm asking myself, -4 divided by what number would give me a 1? Well, -4 divided by itself. So I'm doing the opposite or the inverse operation of, in this case, multiplication. I'm going to divide so that I can undo that multiplication, if you will, and get R by itself. So -4 divided by -4, for me, those cancel because they become 1, and 1 times anything is not there. I don't need it. Over here, -28 divided by -4, that's +7 because a negative divided by a negative is positive. Okay, for number 2, I'm just going to rewrite this quick. I don't like kind of the way it's sitting there for me. Okay, so this one is saying what number divided by 11 would equal -25? So again, I'm looking at h and I want to isolate my variable. I want to get it by itself, but right now it's being divided by 11. So I need to think about how can I make that divided by 11 term actually be a 1? Because I know that h divided by 1 is just h, and that's what I want. I want to get it by itself. So I know that if I go ahead and multiply by 11, I end up with, and I can kind of extend this out, 11 divided by 11 would end up canceling for me and giving me a 1. That's good. And since I decided to multiply on the left side, I better multiply on the right side as well. So over here, these cancel. H is going to equal -25 times 11, I think, is going to be, well, -25 times 10 would be -250, and we could do 25 more, so -275, I believe, is the answer we're after. A couple more examples here. So this time we're sitting here and we have a fraction in our number. So I want to kind of rewrite how this is looking. -13, and my y actually is sitting on top with it. So if it's ever in parentheses like that, just note that the y, it actually goes, or in this case the variable, it always goes with the numerator. And so I'm going to show you one way to do this problem right now, and then when we look at another problem on the next page, I'll show you a different way to talk about that. So this problem is going to be a two-step problem because I actually have a number that's in front of my variable, but I also have division within that as well. So the very first thing that I'm going to do is I'm going to worry about this division part, and I'm going to get it out of there. So again, I want this 5 to become a 1 somehow. So if I multiply both sides by that 5, or what I'm dividing by, then I know that those will end up canceling for me. At this point, I have negative 13y still left because the 5's canceled, but the 13y is still there, equals, and now I'm going to multiply these over here, and negative 20 times 5 would be negative 100, and then the 2 times the 5 would be 10 more, so negative 110. And my last step here then is, now it's a multiplication problem, and so I need to get rid of this negative 13, which is being multiplied. I need that to become a 1, and so to do that I need to divide by that number, and I will cancel those out, and y then is going to equal a negative divided by a negative is positive. And I don't know of a way to simplify that, so we're going to go ahead and just keep that as an improper fraction. We don't necessarily want to make that into a decimal, because when we make things a decimal and we decide to round it, we've changed the number, and so we want to try to keep these as fractions when we can and when we need to. Number 4 is a different kind of problem altogether. Notice that I have a mixed number here, and so the very first thing I want to do, or remind you of, is how we can go about making this mixed number into an improper fraction. So to do that, I'm going to take my whole number, 4, I'm going to multiply it times my denominator, and then I'm going to add that numerator. So I'll just make those symbols on here. I'm going to multiply those, and then I'm going to, from there, add. So this is going to be 4 times 3 is 12. 12 plus 2 is 14. And I actually keep my denominator the same. So 14 thirds is the same as 4 2/3. And so at this point now, I have 3x, and I know that that is being multiplied, but I also have this fraction over here. So this time I want to try to think about this problem in a different way. I could divide by 3, but then I would take a fraction and I would be dividing by 3, and that would be kind of tricky for me. So I'm trying to think of another way, since I already have a fraction over here, that I could make this 3 cancel, but using multiplication instead. So I think to myself, what could I multiply 3 by that would actually cancel the 3 out and make it become a 1? And I come up with this fraction of 1/3. So 1/3 is going to be, so in other words, 1/3 of 3 is 1. It cancels, and x is all that's left. And then over here, I'm going to multiply, and when I multiply fractions, I multiply straight across the top, and I multiply straight across the bottom. And x in this case is going to equal 14/9. And even though we started out with a mixed number here, we're more than okay with keeping this as an improper fraction. All right, number 5, 2/5 t equals -10. I'm going to go ahead and just rewrite that. And this is the problem that I was telling you before. I will show you a different method to do this. Okay? This process right here is called multiplying by the reciprocal. Okay, so in this case, I want this whole number, the number 2/5, to become a 1. To do that, I can multiply by the reciprocal, which in essence, it means that I'm flipping this fraction upside down and multiplying. And whatever I've done on one side, I better do on the other to keep everything in balance. And the reason why this works is when I multiply this out, I end up with 10 over 10 times t. And we know that 10 over 10 is just 1 because those will cancel, and so that works out nicely for me. So that would be 10 over 10t equals -10 over 1 times 5 over 2. And I can go ahead and put that 1 there if I choose. I don't necessarily need to. Okay? And then because those 10's canceled, I can come over here and see if anything can cancel. Remember, anytime I'm multiplying and I've got more than one numerator and more than one denominator, I can check this out and see if it'll cancel. I know that 2 goes into 10 one time. I'm sorry, 2 goes into 10 twice, and it leaves me with 5 pieces left. So now I don't even have a denominator because 1 times 1 is 1. And I have negative 5 times 5 is negative 25. Okay, number 6 is going to be our last one here. I have 11 equals x over 5. I want you to try this one on your own. Go ahead and hit pause. When you're ready to see the answer, you can hit play. So this time I have x, my variable, on top. It's being divided by 5. I want that to become a 1, and so even though my variable is on the other side of the equation, I'm always looking at that variable and trying to get it by itself. So now I have the 5 and the 5 are going to cancel. Over here I'm just going to multiply and I end up with 55 equals x. And there we go. Again, please make sure that you're showing all your work for these problems. These are going to get a little more messy, especially if there's fractions involved. So we always kind of want to have a running record of what happened, and so that we can make sure that we are doing everything that we need to do. So please show your work.